Good morning, kids. This is Nagarjun Reddy. I welcome you all for the third semester. I will be handling the course of electromagnetic fields for your upcoming semester. You might have completed your basic electrical engineering in your second semester, and you might have come across the basic terms of currents, potential, resistance, inductance, and capacitance, right? We being electrical engineers, we commonly encounter these terms, current, potential, etc. You know that current is nothing but the flow of electrons, and potential is some sort of energy which basically drives these electrons around. But the fact is that these electrons, which are nothing but charges, when they move around, they develop some sort of fields around them. Field is nothing but an impact. So the impact which is created by these electrons, the movement of these electrons around their movements, it is termed as fields. And there are two different types of fields. One is electric field, the other one is a magnetic field. And this particular course discusses exclusively upon what is meant by electric fields, how it is generated, and how much electric field is developed because of a current or a charge. And also, apart from the electric fields, how much magnetic field is generated and how to calculate that one, and what is the impact of magnetic fields on the surrounding medium. This is important for an electrical engineer. Why? Because we basically will be assuming that there is a wire, current will be flowing through it, and nothing is going to happen if we are around it. No. The fact is that when a current is flowing through a material, the surrounding medium gets influenced. And what is that influence which is there on the medium? It is due to the electric and magnetic fields. And what are these electric and magnetic fields? That we will be discussing in this course. Okay. And when we were developing this particular course, we have sit with the industry experts and we have discussed with them the inputs which we received from the industry experts. The industry experts suggested that an electrical engineer must have basic knowledge about the electric fields, the static electric fields and magnetic fields, and this inductance and capacitance calculations, what actually inductance is, what actually capacitance is, and how they actually do are present, and how these properties are exhibited. And what do you mean by this permanent magnet, electromagnet, all these terms. The industry experts have given us inputs that the modern day electrical engineers must have very good grip, very good knowledge regarding these things. The electric fields, magnetic fields, how they are generated, how they are measured. So we have identified the knowledge areas, and they also asked us to train the modern day engineers such that an electrical engineer must be able to compute the static, electric and magnetic fields, which generally are generated or arisen due to charge and current configurations. And they also asked us to develop engineers who can really calculate the inductance and capacitance calculations, who can calculate these values. So, and they also asked us to introduce this concept of polarization and magnetization. So you know that an iron material is basically it's attracted by magnet, whereas copper is not that much magnetized, that much not attracted. So what is there which is happening in these materials? So that thing the engineers asked us to introduce to you. So they have asked us this to introduce these knowledge areas and skills to impart to you. So based upon that, we have developed the course into 4 units. Unit 1 deals with electric force and electric field, static electric field. Unit number 2 is about how this field impacts the surrounding materials, and based upon this effect, how the capacitances are calculated. Unit number 3 is exclusively on magnetic fields, and unit number 4 is time varying fields. And we will look at inductance calculations also. So based upon this, we have developed 4 units. Unit number 1, we have categorized as static electric fields. In that one, I will introduce you to the coordinate system, particularly Cartesian coordinate system, the cylindrical coordinate system. You might be seeing that any material, basically, if I want to position it in a graph sheet, we will be having x coordinate and y coordinate. In a 3-dimensional one, we will be using x coordinate, y coordinate, and also z coordinate. All these 3 coordinate systems will be perpendicular to each other. This is a general representation. But apart from that, you see, a wire is basically cylindrical structure. We don't have z, x, and y. So we will be having radius all the time. So how to mention that particular x, y, z in terms of radius? So cylindrical coordinate system, spherical coordinate system is there. So we should know about these things. So I will introduce you in the first week itself. And we will discuss the 2 very famous laws, Coulomb law and Gauss law. And based upon that, how to calculate the electric fields. And unit number 2, exclusively on effect of electric field effect on surrounding materials, what we call it as polarization. So we will get shock even if we don't touch the wire, even if we are in the vicinity of wire, we will get an electric shock. So how it is happening? So that we will discuss in unit number 2. And unit number 3, we will discuss static magnetic fields, where we will discuss the Faraday's laws, Ampere's laws, Biot-Savart's law. So many scientists have discovered different phenomena regarding magnetic fields. We will discuss these phenomena, and from that we will derive expressions for determining magnetic fields. And unit number 4, we will see inductance calculations. This is the most important one, and Maxwell's equations. A summary of all the first 3 units we will see in unit number 4. And after the completion of units, each unit is a separate one, individual entity. So for unit number 1, I hope that since we will be discussing on electrostatic fields, I hope that by the completion of unit number 1, you will be able to compute the electrostatic fields for different configurations. Unit number 2, I hope that you will be able to understand and analyze the polarization. And unit number 3, I hope that you will be able to compute the static and magnetic fields. Unit number 4, again with the magnetization things. So I hope that by the end of this course, you will be able to achieve all these things, capable of understanding this magnetic and electric fields and computing them. And I prefer 2 textbooks, but I want every one of you to purchase this particular textbook, K.A. Gangadhar. It costs you somewhere around 315 rupees. It is available on Amazon, or you can buy it at Zubair Bookstore, Hanamakunda. So buy this textbook. You should bring that textbook, because everything what I teach in the class, you should go back home and go through that one. So Gangadhar, and you take Study Q textbook, reference book number 2 in the library. It may be helpful for you in your unit number 4. And those who wish to do additional things, you better go through this electromagnetic fields in 3D. That is in SWAYAM and PITL course, which is available. And coming to the teaching learning activities, as you all know, there are tutorials which you are supposed to participate. Every week there will be a tutorial sheet based upon tutorial matrix. You should get back to the board and do the problems. All the tutorials basically will be consisting of problems. And coding assignments, I'll be giving you 2 assignments exclusively. They will be based on coding to improve your coding skills. You can choose your own language to solve these things, and I'll be happy if you submit them in time. And don't copy, guys. And special assignments, I think this one also you'll be well aware of. I will be correcting each and every line of your special assignments. These are exclusively for improving your English writing skills. I'll pick one of your students to present on these special assignments in the class, and after that you are supposed to submit me a 2-page report which will be plagiarized. So don't copy. If you copy, you will be caught. Special assignments. And I am introducing 4 course projects. Guys, you may be new to course projects, but course projects do add a lot of value for your resumes. And me particularly, I have identified 4 beautiful course projects. These are all developed these are models, physical models which are to be developed. The first thing is a floating maglev train, magnetic levitation train, where on the track you might be seeing on the track trains will be moving, right? Without physically contacting the track, you should be able to navigate the train. So that is the first project. You should do that. The requirements, I have mentioned it in your course web portal. And super sensitive electric field detector. You go through the projects, you will have a small discussion on this one in the first class itself. These are available in the course web portal. A brief description of what I need on these course projects is also given there. Better go through them. And assessment and grading, you know it very well. 2 assignments, 2 special assignments, 2 minors, mid-examination and end semester examination. And since this is my first time encountering you, simple basic rules which you should follow to clear my course. Already electromagnetic fields itself is a very dry course. You can ask any person of any IIT or NIT, even at the international level, they say that this is the driest course which is available in electrical engineering. But I promise you kids, I'll make it so much interesting for you if you pay attention. So my simple request for you, the first thing is attend each and every class. Number 2, read the recommended textbook and watch the videos. And number 3, work all the assignments on your own and submit them before due date. So 3 things: attend, read and work. And apart from this time we have made a decision that I particularly am going to provide you video lectures. So the moment the video class is completed, I'll post this video in the internet and I will give you the link also. So those who are absent or those who are unable to understand, you can revisit the link, you can go through that one, and if you have any doubts, you just keep a mail to me and I'll respond to it accordingly, and we'll have a discussion session also. So once again guys, since it's a drier subject, don't get feared, I'm there with you. I want you to go through all this content once, attend each and every class and be regular and punctual also, and go through the textbook. Don't forget to buy the textbook, and lastly submit the assignments on your own, tutorials also. Okay, thank you once again, and I hope that I'll be meeting you on Tuesday. Thank you.